Now this is all good until I try and calculate or compare my calculation with another measurement from someone else. So I went online, and on Google Maps I measured that this distance is actually about 257.13 meters, so 257 meters, 13 centimeters. If you convert that to feet, you get an 844 feet more or less. And that's a big difference. Look, that's 450-ish, that's 844-ish. It's a lot, okay? That's almost double the distance. One positive thing about my calculation is that we're both in the hundreds. So this is in the hundreds of feet, okay, 800 feet, and this is 400 feet. So they're at least in the same order of magnitude. But I still want it to be more accurate than that. So I'll try and reflect on what was wrong and what I could have done differently. So I'll restart and reevaluate some of my measurements. Now, unfortunately, I didn't have anything to measure this more precisely, these 30-ish feet, right? So I'll keep this as is in feet. But if you rewatch the first videos that I recorded, you'll see that I was pretty unsure about that first angle of 85 degrees. So this first one, I thought it could have been 86 or 84 instead of the 85 that I used. So if I make this one a little bit bigger to 85, or 86 rather, as a second calculation, and if I make this one also a little bit bigger, you can also see that in the video that this is just over 91, could as well be 92. Then the new angle becomes 180. This angle right there at the tree becomes 180 minus 86 minus 92, and that will be 2 degrees. Now that's a very small change if you only consider that we're moving from 4 to 2. That's only a 2-degree change. But if you think in terms of multiplication or in percentage terms, this guy here is double of 2. 4 is double of 2. You see something similar to what happened before. 450 is about half of 844, right? So this could account for my huge error. Let's do the math with that, the law of sines. This is what I want to find out. So the law of sines, take 2, will be that A divided by the sine of 92 is 31.42 divided by the sine of 2 degrees. So then A will be 31.42 divided by sine 2 degrees times the sine of 92 degrees. And on my calculator, this will be 31.42 times the sine 92 degrees divided by the sine of 2 degrees. And that will be about 900 feet, which is a much better approximation to the distance calculated by Google Maps. So my math was correct if both angles were correct, but something must have been wrong, because there's no way Google's calculation is so far off from mine if I were correct and they were correct too. So another thing you should check when you're doing your own calculations, list the most important thing is the instruments you're using. If you have a stand to measure an angle, that's okay. The second thing you should consider, Like I said, even though a 2-degree angle error made a huge difference because the other angle was 4 degrees, that was a 50% change. One way to make this little error less significant is if this angle is bigger. If this were a 30-degree angle, then we're talking about a 2-degree change being from 30 to 32 or 30 to 28. That would only happen if these angles were smaller so that this guy is allowed to be bigger. The only way for this to happen is for this length to be bigger. So this length being bigger is another way to make so that the errors are less significant. So we can use a bigger length in here. So use a bigger known length. So I guess more steps. So the more you do here, the bigger this length is. And so the smaller, less significant the error on the opposite angle becomes, because that also becomes bigger. Another cool and important thing that happens when you use more steps is that your average step gets closer to the average step of the 29 inches that I used. So if I only take 13 steps, then there's a higher chance that my steps are far off from the average than if I had taken 100 steps. So maybe that's something to consider too. Of course, 100 steps is more difficult, and it's okay if in your project you can't get a pretty accurate estimate. What I care about is that you understand the procedures and that we are able to illustrate how cool trigonometry can be when we use it properly.